To illustrate the notion of constraints, consider this cube again. You'll notice this cube has junctions, and these junctions have different kind of shapes. For example, this looks like a Y junction. This looks like an L junction. This also looks like an L junction. It's just that this arm of the L is coming in the other direction. This also looks like an L junction. This junction, on the other hand, looks a little bit like a W junction. So junctions of various kinds. Here are the kind of junctions that can occur in the world of trihedral objects like cubes. Y junction, W junction, T junction, L junction. We can say a little bit more about each of these junctions. Let us look at the Y junction first. If we examine the various kinds of Y junctions that get formed in the world of trihedral objects, and we find that whenever there is a Y junction formed, then each of these lines represents a fold, where a fold is a line where two surfaces meet. Now, the important thing about this is that if we can infer that this is a Y junction and that this line represents a fold, then it immediately follows that this line must also represent a fold and this line must also represent a fold. Actually, I should tell you quickly that in the world of trihedral objects, Y junctions can have multiple kind of constraints, but right now let's just look at this one single constraint. Similar to the case of an L junction, which has a shape like this, in the world of trihedral objects, an L junction is characterized by this being a blade and this being a blade, where a blade is a line where we cannot infer that two surfaces are getting connected with each other. Again, the L constraint can actually have many more formulations, but right now we are keeping it simple, just looking at one single constraint for the L junction. Similarly, in the world of trihedral objects, one of the ways in which the W junction gets characterized is through a blade, fold, blade. In effect, we are defining a spatial grammar here for the world of trihedral objects. The equivalent of this in case of grammar of natural language sentences might be that a sentence can have a noun phrase followed by the verb phrase followed by a prepositional phrase and so on. Given this set of very simple constraints for the world of trihedral objects, let us see how these constraints actually can be propagated to group edges into surfaces.